Let's look at the concept of cross-laminated timber and glue-laminated timber. You can see on the diagram on the right, a normal piece of timber comes with a lot of different types of defects. So it is not very easy to find a perfect piece of timber that can be free of defects such that it can be used for structural purposes. So the idea of using cross-laminated or glue-laminated timber is that the mass-engineered timber, the defects can actually be taken out, and then after that we use glue technology to glue the pieces with no defects together. And because we are very advanced in our understanding of the glue technology, we are able to come up with a jointing process such that the joint is much stronger than the member itself. So when there is failure, the failure will not occur in the joint, the failure will occur in the rest of the member. And that is how we can get the timber which is of uniformly good quality that is free of defects when you apply this type of technology. And that will allow us to get around having to use timber, natural timber with its associated defects. These are some of the standards that has been used in Europe for the mass-engineered timber. So over the years, they have developed quite a comprehensive understanding of how to make use of Glulam and the timber products. So when the designers and the fabricators can comply with the standards, we are sure of the quality of the mass-engineered timber material, in this case the Glulam. Other areas that use timber quite a fair bit, in America for example, they have their own American standard, or in Japan, they have their own Japanese standard. So you have, for example, standards for boards, standards for structural finger joints, cross-laminated timber, block glue timber, Glulam, so on and so forth. So with the coming out of all these standards, at least we can be sure that the materials, they are of a certain consistency and quality. This particular person, Mr. Otto Hexer from Germany, he was the one that pioneered the use of glue-laminated timber way back in 1872. So over the years, he popularized the use of glue-laminated timber, and in Europe and the other countries, there have been a lot of use of glue-laminated timber over the years. And some of the structures that he has constructed, they are still standing in Germany currently. So that shows you that the timber is also a fairly durable material, just like for concrete and for structural steel. The diagram here shows you the different processes that is needed for us to fabricate glue-laminated timber. You can look at the video clip on how to get glue-laminated timber for better understanding. These are some of the different species of wood that is used for fabricating glue-laminated timber. Among these species, the more common type that is used in Singapore will be the spruce, Douglas fir, and this Scots pine redwood. These are some of the more common species. But take note, they are mostly softwood, and they are not really hardwood. Hardwood are not included in the standards, and they will require a certain separate certification. So there is a difference between hardwood and softwood. So hardwood actually comes from a particular species that the leaves typically are broadleaf, okay, where the softwood, the trees have leaves that are in terms of needles and cones. Right. Hardwood are more likely to be found in a high quality furniture, decking, and flooring. Okay. For softwood, 80% of all timber comes from softwood. Softwood has a wide range of applications, and they are found in building components. Examples of hardwood would be julutong, maranti, oak, teak, walnut. Yeah. Examples of softwood, the Douglas fir, spruce, the redwood, so on and so forth. In terms of density, hardwood will have a higher density than softwood, or softwood will have a lower density. And because they have a higher density, they are more expensive than softwood. And another reason why they are more expensive compared to softwood is that they grow at a slower rate, whereas softwood, they grow at a faster rate. One of the questions that typically people ask when looking into usage of wood for this glulam or for cross-laminated timber is that they always find that we need to import the wood from Europe. And the question is, around Southeast Asia, we have a lot of forests. Why don't we use the wood in Southeast Asia? And that will save having to transport the wood from Europe all the way to Singapore. That is the question. Well, the answer is due to a few reasons. The first reason is that the use of glulam and cross-laminated timber started in the Western countries. So in the Western countries, softwood is the majority of the tree species that is found over there. So over the years, they have perfected the technology in terms of gluing for softwood and not for hardwood, simply because they have more softwood available. That's one reason. The other reason is if you look at the point here, hardwood grows at a slower rate, whereas softwood grows faster. So if you were to use hardwood as a glulam or cross-laminated timber, then it means that it takes a very long time for you to grow the hardwood and harvest the hardwood. Typically for softwood, the cycle is 20 years, meaning that in 20 years time, you can actually harvest the batch of softwood for production process. So you have a turnaround cycle of 20 years. But for hardwood, it's typically more than 20 years. So it may not be so easy to have a sustainably managed forest that produce hardwood all the time. But softwood is easier. That's one of the reasons. And another reason is also cost, because softwood is cheaper than hardwood. And finally, the third reason is that around Southeast Asia, it is not easy to get any companies that can certify that they have sustainably managed this wood forest. So if we were to purchase the wood around Southeast Asia, there could be a high potential where this wood actually comes from illegal logging. And that actually, instead of becoming sustainable, it adds to the problem. So that's why we use softwood from Europe, and we live with the consequence of the increased cost in terms of transportation of the material to Singapore, as well as the time taken. For glulam, the designer will need to decide what is the service class of the member for which the glulam is going to be used. Because different service class will place a constraint in terms of the thickness of the plies that form the overall depth of this glulam member. So the most severe service class will be 3, whereas the most mild service class is 1. So when you have service class 1 and 2, okay, the thickness of the lamina or the individual plies can be between 6 to 45 mm, and it's common to have 40 mm thickness. Whereas if it is a more severe environmental situation, we go for service class 3, then the thickness of the ply is actually reduced to around 30 to 32 mm. And we are allowed to fabricate glue-laminated timber that is curved. You can have a curved member, but again, there will be restriction in terms of the thickness of the ply, depending on what is the service class. That means how harsh is the environmental condition where the glulam is going to be used to form the structure. You can have different densities and different stress values and the Young's modulus for different classes of the Glulam member. The advantage of Glulam lies in the flexibility to have a Glulam that is made from a homogeneous plies or a Glulam that is made from a combined ply. This shows you a Glulam that is made from a combined ply, where we combine the strength. Okay, the top plies and the bottom plies, they are made from Glulam, this timber member that has a higher strength, whereas the middle plies, they are made from the timber member that has a lower strength. So effectively, even though you see a rectangular cross section here, the whole Glulam member behave like a I-beam or a H-beam, where the top and the bottom will have a higher strength, and such a structural member is good for resisting bending. Whereas if you have a homogeneous section, all the plies in your Glulam, they will have the same strength, and then the member will behave like a rectangular section. So this type of member is good in resisting compressive stress. So when you use Glulam, you have a flexibility to decide on whether you want combined or you want homogeneous plies in order to suit the different structural requirements. So the diagram shows you that, for example, for the same grade, you can have a difference between homogeneous material, homogeneous Glulam, or combined Glulam in order to serve your particular requirement, whether is it to resist bending or to resist the compression. Gluing is very important because we need the joint to be stronger than the rest of the member. So generally, the glue will have to be water and weather proof. Yeah, and application, it will be in terms of thin strings. The applied volume is around 300 grams per meter square. Thin glue lines, so on and so forth. And there are different types of this glue material that you can use that are equally effective. So nowadays the technologies is very mature, and gluing is not the point of weakness in a Glulam member. Depending on where you are sourcing the Glulam member from, meaning which country in the Europe you are getting the Glulam member from, different countries may have slightly different standard dimensions. Okay, but this one just shows you an example of a standard cross-sectional dimension of the Glulam that you can get. Okay, but you need to find out exactly the standards available from the manufacturer which you are getting the Glulam from. Glulam is very versatile, and you can have different structural classes, different shapes, and different patterns if you like. For example, if it's a single span parallel beam, typically the span can be around 3 to 36 meters. The width is around 6 to 28 centimeters, so on and so forth. And you can have a parallel beam with a multiple span, for example, and then there will be different recommended dimensions. You can have a parallel beam with a bit of a camber. You can have a tapered beam, and you can have other arrangement as shown in the next slide here, where you can have a 3-hinge system. You can have a curved frame corner. You can have a truss. You can have a frame truss, box element, so on and so forth. So it's really very flexible. You can also get curved Glulam members, okay, but the only thing is that you may need to limit the thickness of the individual ply to form the overall Glulam member depending on the service conditions. If you are willing to pay more, you can actually get the fabricator to go through certain operations to take out some of the surface defects, so that you get a more aesthetically pleasing surface condition. But if you do not want to pay for that, you can just stick with the fabricated condition. So here you can see the applications of Glulam, the different applications and the advantages of the Glulam.